You ever see a headline about some new study and just get a feeling something's a little off? Well, today we're diving into a guide from Stat Harbor Analytics that breaks down the 10 most common ways statistics get misunderstood. Trust me, by the end of this, you'll be spotting them from a mile away. Let's jump in.
You know, this quote from the guide really gets to the heart of it. We tend to think of statistics as this machine that just spits out the absolute truth. But it's not. It's really a tool for thinking clearly when we don't have all the answers. And getting this wrong, it can lead to some seriously bad decisions, whether we're talking business, science, or even just our daily lives.
All right, first up is a really big shift in how we need to think about data. We're sort of trained to look for these perfect, solid answers, right? But the very first myth we have to bust is the idea that statistics can even give us one. It's really all about learning to embrace uncertainty.
So here it is, myth number 1. The idea that a statistical analysis gives you a single, perfect, exact number. The reality? Yeah, not quite. Every single estimate, every one, whether it's from a political poll or a scientific paper, it comes with a range of possibilities and a whole set of assumptions. So the real point here is that statistics gives us a structured way to talk about how confident we are in a finding, not a guarantee that it's 100% correct.
Okay, so now that we're on board with statistics being about uncertainty, let's look at the next place where things can go wrong. The data itself. Long before you do any kind of fancy analysis, some really critical mistakes can be made in just how we collect and look at our raw information.
Oh man, we've all heard this one, right? The study had a huge sample size, so it must be right. Well, that's a classic trap. This myth of bigger is always better is just so dangerous. A massive data set that was collected with a major bias is really just a huge pile of useless information. How you collect the data, making sure it's actually representative, is just as important, if not more so, than how much of it you collect.
Now this is where it gets really interesting. We have to rethink how we see those weird data points. The first impulse when you see an outlier, a number that's way off from everything else, is to just delete it, assuming it's a mistake. But the guide from Stat Harbor Analytics says, hold on, that outlier could be a typo, or it could be the single most important discovery in your entire data set. It might be pointing to a whole new pattern you never even expected.
This next myth, it's a really big one. We love this idea that the data speaks for itself, but numbers never ever exist in a vacuum. To actually understand what a bunch of numbers is telling you, you absolutely need context. Who was studied? When was it studied? How was it measured? Without that information, numbers on a screen are pretty much meaningless.
All right, so we've learned to embrace uncertainty and we've put our data under the microscope. Now we get to the final step. And honestly, this is where most of the confusion for the public happens. What do the results actually mean?
You've definitely seen the phrase statistically significant in headlines. It's designed to sound super important, right? But as the Stat Harbor Guide points out, this is a huge, huge myth. In statistics, significant just means the result is unlikely to be a random fluke. That's it. It says nothing about whether the finding is important or big or meaningful in the real world. That is a totally separate question.
And this just illustrates the point perfectly. Let's say a new drug lowers your cholesterol by 0.01%. Okay, with a big enough study, that tiny result could absolutely be statistically significant. But let's be real, is a 0.01% improvement actually important to anyone's health? Probably not. And that's exactly why you always have to look at the effect size.
And that brings us to the flip side of the coin. If a study is found to be not significant, a lot of people just assume that means there's no effect. Nope, another myth. It could just mean the study was too small or maybe wasn't designed well enough to find an effect that is actually there. It's like the old saying among statisticians, a lack of evidence isn't the same thing as evidence of absence.
Okay, for our final section, we are zooming all the way out. These last few myths are all about the big picture conclusions we draw from data, and I promise you, these are some of the most common reasoning mistakes you'll see out there every single day.
The golden rule of statistics. I'm sure you've heard it. Just because two things are happening at the same time doesn't mean one is causing the other. The classic example, right? Ice cream sales and the number of drownings both go way up in the summer. Does eating ice cream cause drowning? Of course not. There's a third factor, hot weather, that's causing both. That hidden factor is called a confounding variable, and they are everywhere.
We use averages all the time, but they can be incredibly misleading. An average salary, average temperature, an average anything. It tells you the middle point, but it tells you absolutely nothing about the spread of the data. It completely masks the distribution.
Just look at this. It's the perfect illustration. Both of these groups, Group A and Group B, have the exact same average, 5, but they are telling completely different stories. Group A is perfectly consistent. Group B is all over the map. If you only looked at the average, you would miss the entire story. Especially now, in the age of AI and machine learning, there's this big temptation to think that a more complicated model has to be a better one. But you know what? Often, the exact opposite is true. Super complex models can do something called overfitting. Basically, they learn the little quirks of your specific data so perfectly that they completely fail to predict anything new. A lot of the time, a simpler, more robust model is way more useful.
So, after busting all of those myths, how do we actually put this stuff into practice? Well, StatHarbor Analytics boils it all down to a pretty simple mental toolkit that helps you think clearly about any data you come across.
And here is that toolkit, straight from StatHarbor Analytics. First, quantify uncertainty. Embrace it. Second, always question the assumptions behind the data. Third, focus on the real-world importance of a finding, not just whether it's significant. And last but not least, never, ever forget that context is everything.
So there you have it, a brand new lens for looking at the world of data. The next time you see a statistic in the news, you'll be ready. Now that you've got this new toolkit, what's the first study or claim you're going to look at a little differently? Let us know. And hey, if you enjoyed this explainer, make sure to like and subscribe for more. We'll see you next time.